Okay, class, today we will have this explanation on protein. Alright, protein. So I have sent the slide earlier so that you can read up first. So today I will just do some explanation here. So protein is another is another organic molecules that we have as in our body. Okay, beside carbohydrates, okay, fats, okay, we have protein. Okay, we have four macromolecules that is organic in our body. So protein is the second one that we're going to see. Okay, so what is protein? Okay, protein is actually is a macromolecule, or we can call the polymers. Okay, a polymers, macromolecule and polymers, they are the same thing. Okay, macromolecules, we use it when the molecules are big. Polymers mean they are repeating unit in the big molecule. So that's why macromolecule is more general, but polymer is specific to those macromolecule that have subunit that is repeated. Okay, now proteins are made of carbon, hydrogen, oxygen, and nitrogen. Main part. Okay, these are the main elements that is in the protein. Okay, but some of the protein, they will have sulfur, they will have phosphorus, depending on the R group. Okay, the R groups, if you have read up, you know what I meant. Okay, R groups. Okay, so where can we get protein? Okay, protein, we can get it from the meat. Okay, it can be the fish, the chickens, the mutton, okay, or the beef, and also the milk. Okay, nuts, for the vegetarian, they get the protein from the nuts, and also eggs, especially white eggs. Okay, now since this is a polymer, okay, so it is made of monomers. So the monomers for proteins are amino acid, and I believe, okay, amino acid, you have seen this when you learn digestion, right? Protein will be digested, and then the smallest component, or the smallest unit of the protein after digestion, is amino acid, which our body can absorb and use. Okay, now number 4, there are two monomers. Okay, when two monomers, okay, when the two monomers are linked together, the bond form is peptide bond. Okay, for carbohydrate, when two glucose or two monosaccharide bond together, okay, they also have the bonding, we call it glycoside bond. Okay, here is peptide bond. Okay, the process is the same, condensation. Okay, now how the monomers look like, I mean the amino acid. Okay, so since is organic, okay, so it must have the C. So you see the C here. Alright, now if you remember C, we have four bonds. Okay, so one bond here, 1 2 3. So one more bond, that is the C, will be later we will show. Okay, where is the C? Okay, so one of the bond will join to the amine group. Okay, amine means NH2 here. Okay, the ammonia or the amine group. Another bond join with the carboxyl groups. It gets the name of acid. Okay, due to this group join to the carbon. Okay, then the third bond join to the H, and the final bond join to the R. Now these R are the one that is changing. Okay, so if you have different type of mono amino acid, okay, the R side, the chain will change. Okay, in order to form different type of amino acid. Now, what is the condensation process? Okay, if you remember in carbohydrates, okay, we mentioned, okay, just that I not show in detail. So here I will show in detail. Carbohydrates, the monoside is hexagon, so it's very hard to draw out and show it over here. But for this one, since we have a more, we consider easier structure, general formula, so we can show it easily. Okay, so if you have one amino acid here combine or link with another amino acid here, so they must make a bond, the peptide bond. So how to make the peptide bond if all the elements already have their own bonds? So they must remove something. See, here it's been removed, something is being removed. If you can see, the overlapping letter are the H and the OH. So if you are clear about it, okay, if you are understand the H and OH is the element that made up water. Okay, so when this part link together, yes, it will remove water and form that bond. Okay, so we call this condensation. So the water is being removed when two amino acid join together. So the R here and the R here shows that this is two different. Maybe it's a R1, R2, alright, or R the same amino acid also can link together. It's not necessary to have a different one. Okay, so you have peptide bond. Okay, when the two thing or the two amino acid link. So you see down here, two amino acid. We call them when they link, we call dipeptide. Okay, after that it's polypeptide, same as the carbohydrates. Okay, next one, amino acid. What is amino acid? The amino acids, of course, are the monomers of protein. And then this amino acid, you have 20 types of them. That is in living cell. Okay, there are more of them. Okay, just that in living cell we have only 20. Okay, out of these 20 can divided into two groups. One is essential amino acid, another one is non-essential. Okay, you can read from your you can read from the textbook also or any reference book. So essential amino acid, it means that you see here the body cannot synthesize. Okay, non-essential means the body can synthesize. What is meant by synthesize? Build. Okay, when we can build means is non-essential. Okay, so non-essential we have 11, essential one is 9. Okay, 9 type of amino acid. If you want to know the name of the amino acid, okay, you can proceed to Google search, or you can just ask me. I can just show you in the group, no problem. Okay, if you wanted to know, because we no need to memorize all the name. Okay, a few, one or two, maybe later when we come across, I will tell you this is one of the type of amino acid. Okay, now next, just now is amino acid. Amino acid are the monomers. So what happen if this amino acid join together or link together, they will form protein, right? So this protein that we have or we consume, okay, also can divide into two types. One is called the first class protein, another one is second class of protein. It's not the aeroplane, the flights, okay? This is nothing to do with that. Just that first class protein, it contains the essential amino acid. Second class, it doesn't contain the essential amino acid. Okay, just that different only. So most of the time, the first class protein come from the animal protein, and the second class protein come from the plant proteins. Plant proteins such as the nuts. Okay, all the nuts, yeah, cashew nut, peanuts, groundnuts. Okay, those nuts contain proteins. Okay, now after this is the protein structure. Yeah, protein structure. Okay, what is protein structure? So when we say amino acid, this is a monomers. So monomers, they will join together. If you understand from carbohydrates, that's the concept that we have. Okay, monomer join and become macromolecules. And these macromolecules form carbohydrates. Okay, they will form starch, glycogens. Okay, but in animals, okay, the proteins that is formed is from one amino acid linked with another one. So when they link two, it's called dipeptide. So they will link more and more and more together. Alright, more and more amino acid together, and then they form a bigger chain or bigger, longer chain. Okay, you can imagine as that. Okay, so when they form the chain, they must follow the structure. Structure means they can be the simple one. Primary will be the simple one, and then from the primary, maybe it needs another function, so it go to the secondary structure, then tertiary structure, quaternary structure. Okay, what we can see here now, every structure here, they have their own function. Okay, it's not that primary structure no good, then no need. Okay, it's not. Okay, all the protein, in order to become quaternary, it must have primary first. Okay, it start or it build up from primary. From primary, then it build into secondary, and then tertiary, and then quaternary. Then we will see is every protein when function. When they can do their function, they may be in secondary structure, or they may be in tertiary structure, or they may be in quaternary structure. Then only they can function as what the protein is. Take note, yeah, proteins, example of proteins are like your blood, the red blood cell. Okay, red blood cell is inside your red blood cell, the hemoglobin is one of the protein. Okay, one type of protein. Okay, the antibody, alright, is also a protein. Okay, even the plasma membrane, you remember plasma membrane, the surface, we have carrier protein, tunnel protein. Those proteins are starts, okay, they start forming or build up from the amino acid. So it depends on where they are needed. Alright, if they are needed at the plasma membrane, they will fold themselves into such they have a tunnel, so that it can become the channel protein. Okay, so we will go in like, okay, primary structure. So primary structure is when the amino acid, okay, link one by one into a long chain, just like necklace. Okay, the beads on the necklace, one amino acid linked to another amino acid, another one, and another one. So when they are linked together one by one like that, we call them the primary structure. Now normally the primary structure is the beginning of the structure, so it doesn't have much use. Okay, after they form the primary structure, okay, they have to become more stable, more strength, or more stable. Okay, so they will coil themselves, okay, from the chain. Okay, yes, you see one chain here, this is one chain actually, just that from the long chain from primary structure they coil up. So when they coil up, okay, we call them alpha helix. Okay, some of them that doesn't like to coil. Okay, some of the amino acid, the long chain doesn't coil, but they fold. Okay, you have to imagine this is folded, up and down, fold. You see down here, fold. Okay, so if they are in a fold form, we call them the beta platelet sheet. Okay, either they are a coiling one, or they are the folding type. Okay, that is secondary structure. Okay, from secondary structure we can see some of the protein are in use already. Okay, they have their own function. For example, this alpha helix are the protein that make our hairs. Okay, that's why the structure is round or cylinders. Okay, as for this beta sheet, this is the one that made our nails. Okay, nails. Okay, alpha helix here, this also makes up the silk. Okay, silk. Alright, now tertiary structure. Okay, tertiary structure, after they coil and also or they fold. Sometimes the coil structure and the fold structure, the everything, okay, the whole thing fold again. Okay, fold or twist again, so they become the tertiary structure. So here is the tertiary structure. So inside the tertiary structure, you see some are helix, some are beta platelet. So some beta, then they fold themselves some more, they twist themselves some more. It's more complicated than the secondary is tertiary. Okay, so you see here, alpha helix and the beta platelet fold into a 3D shape. So this one, when we say 3D shape, means it will have a shape. For example, the carrier proteins that you have learned. Okay, how the carrier protein got those shapes that we have drawn. Okay, where they carry the sodium and the potassium, how they get the shape? Yes, from here. Okay, the tertiary structure of the protein, when they form tertiary, they will fold themselves to make themselves suitable for the function. Okay, so example of tertiary are enzyme, hormone, antibody, plasma protein, and so on. Okay, when we come across, you will see lah. Okay, we just memorize a few example only. Okay, now quaternary, from the tertiary. Okay, if I have two or more tertiary structure combined, okay, they will form a large complex one. Okay, you see here, what is the picture, yeah. So here, this is one hemoglobin. Okay, Now from this one hemoglobin I can see four tertiary structure here. Okay, four tertiary structure. Yeah, you zoom out one, you can see one, two, one, two, three, and then four. Two is yellow, another two is pink. Okay, so from the four tertiary structure, they make one functional structure. We call them the quaternary structure. Examples are hemoglobin. Okay, so the one example that you see lah, and this quaternary structure, actually your hemoglobin, yeah, you have learned they can carry oxygen, right? So how they carry, actually all this tertiary function, one of these tertiary structures, okay, one of these tertiary structure will carry one oxygen. Okay, the shape is fold in such so that they can carry oxygen. Okay, so that is a little bit on the explanation. So the next part is to the fun time. Fun time is some question that you can do. Alright, actually the answer is there. You just fill in the blank lah, or you answer lah. Okay, and then the answer is all there. You can just ask if you are not sure. Okay, so I hope you have read up. This is the best that I can do for you. Okay, I cannot do classes because classes is actually sometimes it's hard to set the time. Okay, to sit down and everybody listen. Okay, so I rather use this video where you can learn at your own pace. Okay, you can use your own understanding, your own. You can stop anytime, you can rewind anytime to see what you have missed out, or to listen back, or whatever lah. Okay, it's on your own pace. Okay, I prefer this. As long as you have good discipline, okay, you can actually learn, no problem one. You can just learn. Okay, it's not difficult. Okay, bio is easy. Okay, some guidance from teachers, then you can just go ahead. Okay, not difficult at all. So I stop here. Thank you. I see you in next lesson. Yeah.